So this question has the summation notation. So this symbol sigma means the summation of all of the terms. If we were to start by subbing in n equals 1, this lower limit, adding up all of the terms, subbing in every term from n equals 1 all the way to the upper limit, which in this case would be n equals infinity. So we're being asked to find the sum to infinity of this geometric series. Now, first of all, we want to just show that it's convergent. So convergence shows that it has a sum to infinity. And we can do that by proving that R, the common ratio in this question, is between -1 and 1. So it's helpful just to write the first few terms of this geometric series. So we are going to write down the first term, which is 4x over x squared plus 9. And because we start with n equals 1, we sub in 1. And that to the power of 1 is just that term itself. So then we're going to sub in 2, so it'll be 4x over x squared plus 9 to the power of 2. And then we're going to sub in 3, and we get 4x over x squared plus 9 all to the power of 3. And then this sequence, or series, continues on forever like this. We can see that the first term is 4x over x squared plus 9, and the common ratio is also 4x over x squared plus 9. So we start with a term of 4x over x squared plus 9, and that's what we multiply each time to get the next term in the series. So we want to show that this value of R is between -1 and 1, and if we can do that, we'll show that the series is convergent. Okay, so I'm going to take -1 less than R less than 1. I'm going to replace the R with 4x over x squared plus 9, our value of R for this series, and that's less than 1. I'm going to split this compound inequality into two sections. So I'm going to have -1 less than 4x over x squared plus 9. I'm going to show that this part of it is true. And I'm going to take the second part of it, 4x over x squared plus 9 is less than 1. And I'm going to show that that part of it is true. So the one on the left, first of all, I'm going to multiply both sides by x squared plus 9. Now I can do that because x squared is obviously positive because it's a term that's being squared. And 9 is obviously positive because it's a natural number. So if I multiply both sides by x squared plus 9, it doesn't affect the direction of the inequality. So I have minus x squared minus 9 is less than 4x. Now I'm trying to prove this, so this is an inequality proof. I'm going to try and keep a 0 on one side and bring all of the other terms to the other side. So I'm going to add an x squared and a 9 to both sides. And now I'm going to try and prove that this is true. X squared is obviously positive, 9 is obviously positive, but because x could be a negative number, 4 times x could be negative, and so I need to do a little more work on this just to prove beyond doubt that this is true. And the way I'm going to do it is, I'm going to complete the square with this. So what I'm going to do is, completing the square involves writing down the first two terms, the x squared and the x term, and then taking the x term and halving it to give me 2, and squaring it to give me 4. So I'm going to add a 4 to the right hand side here, and that means subtracting a 4 to keep the inequality the same. And then obviously I have my plus 9. So completing the square just involves adding and subtracting the same number so that we can get a squared term in here. So if I take x squared plus 4x plus 4, that is x plus 2 all to be squared. And then 9 minus 4 is just 5. And now I can say beyond any doubt that this is greater than 0. So this is definitely positive as it's a term that's being squared. Or it could be obviously 0 because x could be the number minus 2. But it's positive or 0. And 5 is obviously positive. And so if you add a positive number to a positive number or 0, you're going to get a number bigger than 0. So this is definitely true. And so I've shown that the left hand side of my compound inequality is true. Let's do the same thing for the right hand side. So I can multiply. Well, we write it out first of all. No, I'll multiply both sides by x squared plus 9. Again, we know that's positive. It won't change the direction of inequality. So I have 4x is less than x squared plus 9. I'm going to subtract 4x from both sides to give me 0 is less than x squared minus 4x plus 9. And again, I want to show that this is bigger than 0. And I can do that by completing the square. So I have 0 is less than x squared minus 4x, again, write down the first two terms, take the coefficient of the x, half it and square it, which means adding 4 and subtracting 4, and then the 9 is obviously still here. So we've only added and subtracted the same number in this question, so we haven't actually changed the inequality. So 0 is less than, I'm going to make a square out of the first three terms, so that's going to be x minus 2 all to be squared, and then plus 5. And again, we can say that this is definitely true because x minus 2 squared is greater than 0, or it could be 0 if x was the number 2. And then when you add 5 to something that's positive or to 0, you get a number bigger than 0, and so this is true. And so the left-hand side of my compound inequality is true, the right-hand side of my compound inequality is true, and hence we know that the original statement is true, and minus 1 is less than or is less than 1, and the series is convergent. Okay, so now we're going to try and find the sum to infinity of the series. Because it's convergent, it has a sum to infinity. The formula for sum to infinity is that S infinity equals A, the first term, over 1 minus R, the common ratio. And so this is just going to be algebra to find this sum of infinity. So I'm going to sub in A first of all, which is 4x over x squared plus 9, and I'm going to, on the bottom, have 1 minus R, which is also 4x over x squared plus 9. I'm going to get a common denominator in the bottom of the fraction, so I'm going to keep the top as it is, 4x over x squared plus 9. So I pick a common denominator of x squared plus 9, and then 1 into x squared plus 9 goes x squared plus 9 times, and I multiply that by 1, minus x squared plus 9 into x squared plus 9 goes 1 time, and I'm going to multiply that by 4x. I can see that the x squared plus 9's will actually cancel, and so I'm left with 4x over x squared plus 9 minus 4x, and that's as simple as we can get it. I might just rearrange the quadratic on the bottom, x squared minus 4x plus 9, and this is the sum to infinity of our geometric series, and obviously in terms of x, where x is a rational number.